Hey everyone, I'm making this video to announce my new project, VKEngine, which is going to be a 3D rendering engine created with Vulkan and C++. And in this video, I'm just going to discuss my motivations for doing so, as well as the dependencies I'm using to build it. So if you've been following my channel at all, you'll be familiar with my previous project, OGLRenderer, which was a 3D rendering engine created with OpenGL and C++. And as you can see, I got pretty far with this project. I implemented quite a lot of rendering techniques, and I was pretty happy with it overall. So here's a quick breakdown of the main things I accomplished with this project. I had physically based rendering, image-based lighting, dynamic lighting and shadows, and a post-processing pipeline, as well as a scene editor where you can move around, add models, and change everything at runtime using IMGUI. You might be thinking, why build a new engine instead of just extending this one, right? And I have a few reasons. The main one is that Vulkan is faster. Since Vulkan is a lower level and more explicit API, it reduces the overhead and allows you to unlock higher performance from your graphics applications, which is why Vulkan, along with DirectX 12 and Metal, have been widely adopted by the industry. And if you're looking to work in this space on greenfield projects, you're definitely going to be working with these APIs, right, rather than, say, OpenGL and DirectX 11. And also, Vulkan being low level and explicit does make it very hard to learn. But you might find that once you get over this learning curve, it's actually easier to reason about the behavior of your program because Vulkan doesn't have any global state, for instance. And also the debugging experience on Vulkan is very good. You're never going to find yourself just staring at a blank screen. What's the current status of VKEngine? Well, right now I can just draw a triangle on the screen, which you might not be thinking is very good, but it actually took about 1,000 lines of code to get here, and I created an entire rendering architecture to enable it. And that's because in Vulkan, we have to do all of the work up front. So extending this to draw textures and 3D models isn't actually going to be too much more work. I've already done the bulk of the work just to get this up and running. And in terms of feature work, the first thing I want to do is achieve feature parity with OGLRenderer. And in doing so, I'm going to adopt all of the modern Vulkan techniques like dynamic rendering. And then I want to implement the following features from my original roadmap, such as deferred rendering, cascaded shadow maps, skeletal animations, frustum culling, and probe-based global illumination. So the dependencies I'm using to create VKEngine are obviously the Vulkan SDK with the validation layers, the Vulk loader to load all of the extensions without having to use function pointers. I'm going to use the Vulkan memory allocator from AMD for buffer and texture management on the GPU. And I'm using GLFW for window management and input handling. I'm using GLM for mathematics library, DIMGUI for the UI, S2B image to load textures, so PNGs, JPEG, and HDR files. S2B image doesn't actually support EXR or compressed textures like KTX, so I might change it out in the future. And I'm using TinyGLTF to load the 3D models. I'm just going to support GLTF 2.0 models rather than using ASIMP to support all different file formats. Just seems easier to strip it down. So thanks for watching this video. If you're interested in the source code, you can find it here. And if you're interested in learning computer graphics, I actually maintain a list of resources on my personal website that might be useful to you. So feel free to subscribe if you want to follow along with this project, because I'm going to be posting more videos in the future. Thanks.